OK。
回头把这个打开之后用完都装这里头啊。
有的，
要不然
那为什么不装这里呢？
等着你们的。
Yes. Can you do one for me? Each group can choose one and do platonic solids for me.
什么意思？
啊，我不知道中文叫什么。
做一个正多面体。
哦。
OK。
好，行，我们点。
哎，你们那边那么多球呢？现在这个正负面体吗？
怎么还有？
电脑上点了。
对，让他们先拼这个，每组，哎，没事，每一个组给我拼一个。
正多面体。
对。
老拼个正面的，不简单。
我这个实在没法拼。那这样吧，我先拼正四，然后给你。我来拼正四，我是不是也
你说你拼正六。
正六我是最不赞成的，但是我愿意挑战自己，这块我觉得。不是正六肯定。我也在拼，你们不要拼。
球不够。能借我们点。
那你来起。
那一组一共是20个球。
你看我们才几个？
对呀，自己好意思说吗？你在，因为你一个人在。
不够再要他们要，不一定每个人都需要那么多，是吧？你现在分了没用。OK, number one.
我也想写另外的词。
这是个标嘛。
没事，我们不让你高兴，这6面体很好笑。
这个是美国。
像不像一个动物
？Perfect. OK.
Oh no, no,
是
not perfect.
Not yet. 少了一个。
练。而且我们绿色的小短棒缺了好多，怎么办？我能先拼个不怎么标准的吗？因为绿色小短棒。
那还有啊，这不是有吗？
但是只有4根啊，而且。
在前面再从其他地方要呗，让他们做，不要用绿色的，或者你用蓝色的也可以啊。
但是蓝色的。
紫色的，只用紫色的也可以。OK, that's good.
哎呀，我的正手能力不行。
Okay, we have 1 cube, 2 cube. Okay.
啊，这个正8面你拼不正我。啊，对，是不正，你再拼个0。
老我有个问题，好像正四面体好像正四面体好像没有3个60度夹角的。
换一个。
有可能这个
是得用红球吗？
有可能不行，有可能要用点劲儿，因为不是完全那么多度，70几度吧。
一个大的，一个小的。
Yeah, maybe the
不是老师，我的意思是说找不到3个60度的。
没有，不会啊。
60度旁边的话，它就是45度了，它就没有60度。
他们也做了呀，你看。That works.
不是你那60度是怎么拼的？
这根绿什么？
这块有绿的吗
It works. Example by example. 有，可以。
什么意思？
他们可以。
这个是
他们用的是黄色的，然后有60度。
这样吧，
我问题这是45度的。
球，我都拿去拼了一个了，这边有人也拼完了。
Okay, we need something more complicated, guys. Yeah. 要个 What else do you have?
球太小了。
Huh?
I think we just 就是我们的球只够拼个正6了，才刚。对啊，我们的球实在不够。
哦，那你就问他们要呗，或者我们拆一个。
他们不给，说我们。
哦，那我们拆一个。
对呀。
那好，我们拆
说我们不需。
我们拆一个 ，OK？ 小的要小的还是要大的？我们拆一个。
我们要小的啦。
要小的 ，Is that okay? Yeah. 猜呗。
然后最后2条拼不上了。算了，正八就拼不动。
为什么？哦，为什么？
拼不了一点点。
因为这个东西没有这个60度的是吧？
所以说
不够。
拆了吧。没有连是4个60度。拆了吧，因为那个我们那个球数不够。
可以。等一下 ，Why not this way? It's fine. 就有劲儿呗，就。No. Yeah.
不是小爱，我们都快没东西。
Okay, let me try. 这是拿来就看那个图上，他们不是也有解释的吗？
我根本就没有。
你们没有吗？ Oh, there's this one. Oh, sorry. Oh, sorry. Here.
都在盒子底下。
我们没有和你啊。
You can. I mean, come on， 自己想怎么用，不要看说明多没意思啊。别看OK， 这个有点 Why is this? That's stupid. 有一点儿，
然后这个玩意儿，
这是哦，这样子可以 ，That's fine。
一个球本来就有这个图形啊。
对，这个算是8的吧 ？OK。
That is not perfect. Cause.
Okay, we take this one instead.
Yeah.
It's not good. I need to. I didn't look at this. 没看啊？我觉得也是。哦，不准给你这个只 cube， 我们有一个 cube。OK， 得跟他们说一下这个东西好像洞不够。那你们得打洞呗？有没有打洞的东西啊？打洞就是了。OK。
I got it. I think I can make just like a little one inside the bigger one. That's more than it. Oh no.
Okay. Well, okay. We have a tetrahedron. Perfect. We have一个。Yeah. Well.
拼完之后拆掉。
Okay. We have a cube. That's fine.这太限制了，得多打几个洞。
A perfect triangle.
Okay. Let me ask you something. Okay, 我问个问题啊。What is a platonic solid? 到底是什么意思？
每个面都一样。
每个面都一样。OK。我用英文写啊。
每个面应该都是正多元。
And what else? 还有什么？还需要什么？
Let's draw about to make tetrahedron. 我们用我们的球共同做一个我们没有。
我觉得。
你可以把那个拆了呀，我们都做好了就拆了不就得了？
对，然后你们如果实在不行了，就自己打个洞。这东西可以就用什么东西打个洞就是了呀。不，这东西只是塑料的，你们打个洞就是了。
球不够了。
球不够了，对，我觉得这上面的洞太少了，那自己打你用圆规打不行，太小了。这东西你要打那么大这个洞需要个东西。
老师虽然但是，但我还是认为这个似乎做不了这四面体。
对，对，也四面体他们做了的。There。
四面体做不了，老师，四面体的只能拼那种题。
可以。
可以啊。嘿。
哦。
我们这边也有。
So this one, you see? Hey. Sure. We are just playing right now, but you can join if you want to. Hi， 我们在玩呢，所以 it works， 可以的，你看 ，OK。
正四。
Yes, but I think there's not enough holes in these balls here to do the pentagon. Not enough, not 72-degree angle. 没有72度的东西。
所以说拼不了12面体，然后一个面也不可能插就是5个过。
对，我觉得要重新打洞，这东西不行。
对。
我有没有想到？
要不然就是要用多点劲儿，或者是打洞。对，我觉得是应该打洞，直接打洞，没关。I think it will not be big enough. These are very small. Yeah, 我带一个，我看是多大的。
找个球啊！
然后这样好像也捅不出来，这质量非常的好，好吧？良心商家。
这东西不行，这样子不行。对，我下次带一个那个what is it even called? The drill.
太强了。
I bring a drill next time. I have a drill at home.
这良心商家。
多面体骰子吧，多面体骰子是不错的选择。
OK。
良心商家，这都找来。
So，
还不拼，老失败了。
失败了。
一个小。
Yeah, we'll need to bigger one. Yes, perfect. 说中文吧。
4面体6面体都拼完了我。
可以，然后其他的呢？
然后这8面体似乎能。
You want one as well? Oh, I'm not sure they have enough. But so I only have they only bought 3. So the idea is to do platonic solids, but then there are not enough angles on these ball thingies. They're like restricted to 60 and 90 degrees and 45, which is useless. So you have to drill new holes into these things. But okay.
Oh, I think 75 degrees is enough for approximation.
Is there 75 though? So there's no 50. Yeah, well, there's 15. Maybe. Okay.
Oh no.
尝试打洞。
Did you get any? Okay.
好奇怪呀。
Okay. So week homework is to drill enough holes in these things that we can do all the platonic solids next time. Okay. You can do it during the week. Yeah. Yeah. They should have just bought more, and maybe they needed these vertices to be more flexible. I didn't pay attention to that one.
我什么意思？
进几个球？你们这块球是比较进几个球
How are you thinking and how are you going to think?
我们并没有同意的。
我拒绝。还是拒绝。
Okay. Did it work?
小爱，
不要把里面那个圆规搞坏了。
那个没用。
没用是吧？哎well. Okay. 当然可以啦。
然后我们硬生生把这8面体做成了。
剪刀呗，我戳个洞。
I think it's case by case, but obviously also.
Yeah. So the idea for today is this one first, and then we would classify platonic solid later.
Like with the proof.
With the proof, of course.
Oh, nice.
Oh, I mean, that kid read Hartshorne, so don't.
What?
Hartshorne, the algebraic geometry.
No,
Yeah, I know.
Geometers.
Oh, yeah, just saying.
老师正八。
Yeah, kind of. I asked them. Yeah, there was just don't be. It's not children. It's not. We're doing. So I'm actually doing axiomatic geometry, like elementary geometry. But so we want to do platonic solids, and then I continue with the axioms. And then I mean, the piano axioms, all of them can know by heart, and just so so just yeah.
Okay.
And the idea with these solids later on is, so in 2 weeks or 3, I will do soap bubbles with these solids, and then you can see that the minimal, then you can see that the minimal surface, how the minimal surfaces with these boundary conditions would be. That's the idea. 10 to 13 apparently. Yeah. So they still like to play. So last time we cut Möbius bands and so on, because I think they learned so much out of books, but they didn't really play with the math things we know normally, right? You didn't really play a lot with the Möbius bands, so you should play more. And then later on, so the goal actually eventually would be discrete differential geometry. So later on they can do differential geometry. So they can do discrete models of surfaces with the set as well. So that's for the next weeks.
That's really cool.
Yeah.
我们想把这个正方形。
可以。你们合作嘛？你们没不够的话，就跟其他孩子们一起合作，然后就可以做的复杂一点的。No, I had the choice whether to program it or do it in live. I thought it's with things like nicer. Okay, we need more of those. You can keep this one as well. That's nice.
然后我们做的鬼畜的正八。这个面是三角形，这个面是三角形，这个面是三角形，都是
Very nice.
这不是球形吗？这说明这是球。
哎，等下你看看这条边，这个是三角形，这边也是三角形，这边也是三角形，这边也是。其实可以，这个特殊是很经典的一个，跟那个玩意儿其实挺像。
玩这样的，好像这种。
绿光的跟号2倍。
而且正八，哎，还在他脸上。哎，你看别把，我有一个比较好的。
I find something amazing. 首先把这个球搭出来，然后这玩意儿可以帮助我们制造一个正八面体。就是我们先把这个球搭出来，然后这样的话它就稳然后我们就把这个蓝棍儿这么着按孔这么给它插上，然后等到时候我们再把就是我们逐步用蓝棍儿取代这个球。
可以试一试。
有点废。
这是什么呀
I don't know.
I think that's
Okay. So if you want to, so the idea eventually would be discrete differential geometry, and I want you to do surfaces with that, yeah?
yes.
Okay.
你还有哪？
Okay.
你等一下，我 108 angle.
Yeah, that's bad, right? So we need more. We need to put more. I will take.
I'm wondering how are the holes being manufactured?
I bring a drill next time with me, OK？ 我带个那个打洞的东西机器，然后就直接打孔。
老不是这个制造这个的商家非常的良心，导致这个材料太结实了。
对，我没想到这个我没想到这种材料连这种 platonic solid 都做不了。啊
They are solids.
？Yeah，
Solids.
这质量不错的哦。好吧。
Wow, good quality.
太好了。不行。我们想做的都做不出来，没事。
商家太良心了。我使劲家都没整。
下次来打孔吧。
让我想想有没有什么好的办法。
可以做大一点，然后就那个 that's what you're trying?
The green stick
Very good.
times square root of 2 is equal to the blue stick, and the blue stick times square root of 2 is equal to the purple stick.
Yeah.
1跟2的。
Yeah, if you do it bigger, then it's more flexible. That's true.
Actually, that's not precisely. Not precisely, but
Not precisely.
Almost.
just approximation and that's
Approximation.
Like back in the day.
You will always be asked for some errors.
对老师，然后就是我另外一位球不够，
很正常，他那个
球不够了啊。还在这边搞呢。
你要做一个伪球体吗？伪球体。
That's nice. That's very nice. That one we need to keep. I need to.
Wow. A cube with the side length of purple plus blue.
这个
That is pretty.
球应该更理论上来讲。
你的操作实力 it's really hard for me.
老师如果要把它从球改
Yeah.
老师我们发现一条伟大的定理，如果我们要把它从球改到这个正八面体的话，我们需要好好给它回炉重造一下。
差不多还可以。
不然就会得到一种非常
像这四个也可以改，这个好像就不行了，这不够长，有可能。
让我想想，理论上是可以的，但实际上又不是理论上。这是我读属于我的废话文学。
哎，对，其实还是可以的。
可以吗？差不多。呀，应该是可以。
但理论是理论，现实似乎是哦，我正做孔了。
Okay, nice.
注意到我有没有球？
哦，我没有。
Very good. 可以。
还行。果冻。老师做出来的。
可以啊。Now try the.
Platonic but not solid.
Yes.
反正适合你。
可以试试那个，可以试试。
Not solid.
Try the pentagon with the pentagon faces.
它为啥做伪球？
Oh, that's very nice. Let me take a picture. That one is nice.
地面不错，懂一点。
That's very pretty. Oh, that's a hat as well. 也可以戴着帽子是吧？
那是硬的。
绿帽，蓝绿帽，蓝的绿帽，
有一点点好笑。昨晚上个房。
在这场。
完了，然后我发现这玩意儿做不了正八面体。
对，好像叫啥名字呀？那孩子。
质量不错，给我带。
李成，对，好像可以，他多加了几个。
帽子质量不错。
对，这蛮好看的是吧？
伪球面帽子。
哎，等会儿，我还有一个想法，
帽子，
就是这上面再加个小尖儿。
没了，没。OK，不错。
可以。
可以给大家看一个。
对。
魔术帽了。
就变成顶上是尖的绿帽子了。但是好，我们没有做角度。
我觉得这已经很漂亮了。
角度被割了。我 I need and only need 3 balls。OK。需要且仅需要3个。Thank you。
方帽子，但是我建议以后就是看这个帽子，这个东西。
我也不知道在打什么了，非常奇怪。
我能把你这个包帽子拆了吗
Yeah, I think the idea was a pentagon, right?
Yeah, I'm trying.
Yeah, perfect.
They are more flexible, so maybe using this structure to make them pentagon is
Yes.
available.
你这个不应该是90度，应该是120度的。能不能你把它给拆下来换一个？有啊，是这种30度加90度。
Wow, we have it.
然后
差不多。
然后这两边是那个根本连不上。
Yeah, well, that's okay. It's kind of an octahedron. Almost. It's actually stable at least. Yeah, it doesn't fall.
Can I ask you a question? Is the polygon, can it change in the same solid?
What do you mean by change?
Like, does it have to be the same?
Yes, I mean define define the thing first, but
Can it vary in the same platonic solid?
by definition not.
By definition, it has to be the same angle.
Yes.
For all.
I mean must be the same. Yes, must be the same. The idea is so, and actually there's lots of couple of lines missing. They are concentrate on this one right now, right? We will make it do it later. Oh. 等一下，我先修一下。They're slightly constant. I destroyed the thing. I'm like, ah. Yeah.
这肯定不是正五。
嘿，修好了。
正五边应该是108。
可是你有没有发现这两个角度不一样
Okay.
这个角度是120。所以说你跟他
All the faces.
没办法，制造商制造太好了。
对，所以你捅不出来有
制造商做得很好，导致这种形不能被捅动。
不做正
这种形都捅不了动。我觉得这球也不够了。
这东西对，这有点。
让我解。
So, you have to collaborate with others.
Yeah.
Yes. I cheer 吗
I think maybe this is bigger.
Yeah.
大圈。已经打好了。
Okay. Does it work though? Is there? So, I give you another 5 minutes and then we continue with the class. Okay, then you have to abandon the toy. Is that okay?
Of course I will.
Of course you will? Good. 5分钟 OK? 再玩5分钟。
哦，跟我来说不一样。把它搭
起来的话，难度比较大。
OK, 5 minutes, 5分钟，然后就上课，然后。
我的 God！
因为的话，就是在做一些奇奇怪怪的。
Oh well, I want the pentagon.
没有足够的球。
老师，你喜欢这个负曲率的曲面吗？负曲率的曲面。Negative curvature. Yeah. Curvature. Yes. Negative curvature.
强行抓手，感觉有点不稳定。
Stable. No, sorry, I can't.
这玩意儿是实心的，然后鉴定完毕，这玩意儿的质量极好，这玩意儿是实心的。
快点儿，
老师没有用，他没有。
还有3分钟，还有3分钟啊！
对，让我数一遍。
Cold warm。
一共是12个。
这了。
一共是大约30个。
小王爷。
绝对不能。
这科要研究的是要引入角营的概念吗？角营。
什么是角营？
就是说每一个多面体在一个点处多出来的角。要是你想要讲微分值的话，我可以借他一些气球，气球是很好的，气球很不错。
Perfect.
Wow.
Very cool. Okay.
I think of
Okay, we have a
sodium chloride.
use sodium chloride. Okay, perfect. That's lovely. Very cool. Well done.
没有球了。我算了一下，大声这个需要30个球，而每个足值20个。你们是在考什么？
那我送你5个球。
Aim at you.
Okay, we made a pentagon happen. That's good. Not octahedron.
哦，这个球。
谁要球？
我们只拉一个那个，然后就有9个球。
给你。
成了。现在就是还差3个球，2个球。
我们 fire 谁呢？
One last minute, and we have
瞄
to.
准了我。
Then we have to
老师感觉比较
start the class, and we don't need to destroy it. We can just put it in the shelf here. You can just put it on the shelf. You don't need to put it back. Okay. Okay, we keep it. Okay, we keep it till next time or something at least. Look at this. Okay, perfect. Negative curvature, yes. 再要一个球，有个球，还有个球吗？
还有个球。
缺一个。
缺一个球。
没了。
志彤，你还有个球吗？
妈妈把你上面那个球拆了，前面那个球拆了。
这个可以吗？
没有，必须要一个。
可以不要球。
反正不稳定。
很大的6人柱。
非常大。
Thank you.
Hexagonal prism.
Okay. Then you find a place for the thing.
一个非常的不稳。
Perfect.
挺好。一共用30个球。
Perfect. Let's move it to.
老师感觉。
可以。Let me.
Wow, how big it is!
Wow, big.
That was unintended.
Oh no.
Let me just put it here. Does this work? Okay. Good. Clean up everything.
Yeah.
The rest of it. Yeah.
No.
Okay. Perfect.
No.
他不知道。
不知道。 Okay. Have you? 放到柜子里面去。So we will need that later. Okay, hopefully. Oh, what happened there? You need paper? Okay. Let's start the class properly. I hope you had a bit of fun. Okay? Okay. What is platonic solids in Chinese again?
正多面体。
正多面体。
正多面体。好的，那你们把那个定义给我说一下。OK， 我们已经有2个了，还有什么？缺什么 ？What's missing? What do you think is missing? How many are there? Which one do you know? 有5个，对。What are the names? Oh, well, it's bad. It's tetrahedron, and then my goodness, cube. Octahedron. Full dodecahedron. And 5 icosahedron. I hope I write it correctly. I'm not. I know the words better in German, and the hedron thing I'm not completely sure. Okay, it's this thing means 4, 8, 20, and whatever that is, 12 probably. Okay, perfect. So why are there only 5? 为什么只有5个
Use the Euler formula. That's
Which formula?
Euler formula.
Which formula?
Euler.
Okay. Which is?
E minus E plus F equals 2.
What? E?
E minus E
plus F equals 2. And then you can get a fraction of those things like all the, maybe the regular n-Gauss number of n, and it's like how many phases is it, and you get the fraction. And then that they are all integers, and the equation has only 5 solutions.
Okay. So now, does this formula hold always? So, yeah?
It's actually better now.
What are the assumptions so that this formula holds?
That one is just like homomorphism to S2. Then
it is not. You can a big cube and
What?
就是一个大正方体挖出一个小正方体。
Oh, yes. You can remove a little cube from it. What is it topologically? You have a hole in it, right? Then of course, this formula doesn't hold. Yeah, exactly. Good. Perfect. So that was this about, what this was about. And next time, or rather in 2 weeks, the idea is I need to add some tweaks to this material here, but then we want to do soap film. So we want to do an experiment and dig the thing into soap, okay, and hope to see whatever happens with the soap film. Do you have a guess on what it could be? If you have a cube, where's the cube? We don't have cube. Well, if you have so if you have a cube, okay, and you dig that into soap water, what do you expect? What would happen? What kind of film do you have? What soap bubble you would think? Yeah, it's a minimal surface. That's correct. But how would it look like? So you can think about it for 2 weeks, and then we will do the experiment live. Before that, I need to test my recipe for the soap because it needs somehow baby shampoo and a lot of sugar and whatever, because that makes the best soap for this type of experiments. But I have a recipe somewhere, but I need to test whether it works with these things. Okay, so now what you have said about the proof, right? Now we go back to our axioms of last 2 times. What would be needed? Okay, what kind of theorems do you need to actually apply this proof, right, coming from the axioms? What do you think will be needed? Yeah, we don't have that much yet, right? So shall we just repeat what we have? Hmm? 什么是消去？
Add elimination and
It is like give.
cutting an edge, or
No. What I mean is, so last time we had these axioms, we had ordering and congruence, right? And we were like, what we have last time basically was we had the ruler, we had a compass, right? And we were like about to show that if you have starting at a point A, and if you have a line or ray L, then for a given distance, you would have one unique point in that side of the A, right? On L. Yeah. And then we had that there's a minus B if you go on the other side, right? And that on these points are uniquely determined, right?
Now we have circle.
And then we have a circle, exactly. So now the question is how to use this proof starting from there. What is missing? Because if you want to use this formula here, right, there's still a huge gap from you can only have 2 points on the line, right, to this formula. Yeah. Okay. First, define E and F. What else? Well, I think the proof doesn't necessarily, well, you need some bit of, but actually the proof could be, simpler, right? Okay, and also in the definition, of course, it's kind of convex, isn't it? And just to make it vertices. Same number of faces at each vertex. So one can do it this way, which is kind of higher technology, if you like, easier one. Can you think about another proof? Think about another. No, easier. It's an easy theorem. Yeah. We use easy techniques. Okay, we don't throw cannons at little birds. Yeah, we want something to be to the left there. Okay. So think about another proof. What is simpler and has more to do with what we have done last time. What have we done last time? We defined circle, yes. We defined angles, right? And we defined segments. And we talked about in-betweenness, etc., right? So how to define or find a proof that has much more to do with things like angles and triangles,
use this thing first, and like we can
说中文。
就是把它拉伸一下，然后就让这个多出来一条边，然后这样的话就多出来一条边，然后就会多出来一个顶点，然后就是遵循这种规律，就证明就是不断把大线段分割成小的。
把顶点弯，把边弯了，把顶点。
那你弯了以后呢？
把边弯了。
就是弯了的话，然后就是肯定会加顶点，然后就是不加顶点就会加面，就会加面。
你们想证明这个吗？你们是想证明这个 formula?
Yeah.
Well, I'm talking about a completely different proof of Platonic solids thing. This one we can do later. It's not. Okay. What is the easiest, like, 5th grade proof? Okay. You only have angles and the definition. So let me ask you something, okay? What is the angle regular inside a regular angle? Give one angle. Okay. What is the formula for that?
端点是同一点的两条射线吗
？I don't understand. 什么端点？再说一次。
是一点的，就端点为同一点的两条射线。
我问的是那个角有多大？那个如果你有n 个角的话，然后每个边儿是一样长，那么那个角有多大？What should it be?
This should be n over n minus 2 over n.
Yeah, it's n minus 2 over pi. Why?
That's because we know that the angle has the sum of its inside angle and its real angle is n minus 2 and n minus 2 pi, and there are n angles in it, and hence each one, because it is regular, so each one is n minus 2 over n pi.
Yes, but why is the first one true? That the sum in the angle is whatever.
就是把那个中心找出来，然后就其实找出来内部一点，然后
You can just first we just prove that all triangles.
然后把这些都给分成这么着。
Correct. Okay.
然后
Okay.
有小三角形内角和180，然后中间有个这个周角，然后就n减2分之 n。
Exactly. You can do it that way.
可以给它分成这样。
Yeah. Right? Should I repeat? Should I repeat? Yes? So, one way to do it is to take the midpoint and then connect with each of the thing.
And there are totally n, but
Right? So, each is pi. And, well, if you don't want to subtract, the other way to do it is just to connect this one. Like this, this one. This is okay. So you have n minus 2 triangles. Okay, perfect. So now, when you have the question is, what we need from our axiom is how to add angles. Okay? The second thing, what is half? Well, what is pi? What does it mean to have an angle pi, pi half, 2 pi, etc. Okay? So we haven't defined it yet. So this means we have to say what it means to take half of an angle and double of an angle, okay? Okay? Just to remind you, when we have the lines, we had here 1 and -1. Yeah. So we can start at B again and add this 1. So we have the integers on the right-hand side. We have the negative of the integers on the left, so we have Z, okay? Now the question, how to do fractions on the line. That's easy. What do you need?
You need this, the positive part of it and the direction of positive one and the whole lot, the one whole lot.
Right? Come on. Just try to. What do you mean? So what is still missing?
You mean fractional?
How to do 2/3?
Okay.
2/3 of AB.
Okay. Oh no, but you cannot.
Okay. So we haven't. What didn't we have last time? Did we finish the axioms or not? No. What is missing? So we had incidence, right? We had ordering and congruence axioms, which meant that we had the ruler and the compass, okay? Now what is missing? The most important or most famous one at least? That's compass. What is the most famous axiom? Because it's not always true or don't need to be there.
Parallel.
Yes. So we don't have a parallel axiom. And the second thing that is missing is we need that the line is everything. Okay, that is dense. Okay. So that is no gaps. So let me write it properly first, what it means. Okay. It means, first, according to these axioms, we still don't have that the line is R. Okay, right? It could be Q, it could be whatever, but we don't have it yet. Okay? So we don't have, and for that we need these no gaps. But what does parallel axiom mean? It means when given a line and the point A not on the line, there exists a unique H through A parallel to L, meaning they don't intersect. Okay? So when I have that X and I have A and B, well, maybe not B. We take a smaller b, and by one of the axioms, you have exists a C on the line with B in between AC, right? So we can draw it this way. And we take any angle and have another line here. And what we can do is to divide this line, well, basically we're using the same length into, for example, 5 different pieces. Okay? You get it?
Yeah.
What happens then?
I think that's a question I thought when I was young. I think maybe.
Did you, when you were young, did you just say when you were young? So what does it mean when you have that, right? How to proceed? Okay. You want to draw? Anyone want to draw?
Okay.
Well, wait, let him, and then you are the next one.
So.
You can draw with your left hand.
2 over 3.
For example, you can do 2 over 3.
3 and then. Wait. I think there should be this. And.
Well, you can do whatever. Yeah, you can do that, for example. Try it. How to get the point in the middle? You just draw. You know how to do it? Yes. How do you get the points down there? How do you get the points down there? Here. How do you get the points here?
Like this.
Okay. So how do you get this point from here? How do you get these points first?
Because this is 1.
Yes. So this is yeah. What is this is 1? Yeah.
Yeah.
Okay. This is 1 as well. Okay. And then?
And then you just copy one of it.
Where to where?
This part, and you just like this. You can do this one.
So how? So these. What is this?
They are 1, 2.
Okay.
The 4.
Like 3 ones on this side, and then you connect this one with the end point. And how to get these then?
They are parallel to it.
Yes.
This is the third one.
Yes. Okay. Okay. And now you need to, of course, to prove that it's true, but that's, well, yeah, just. Yeah. Okay, you can think about why this is true, that this is now 2/3. Okay? So with that one, parallel axiom, we basically get the rational numbers. Okay? Now, what we need slightly more is continuity, or that's what they call continuity, to get from the rational numbers to.
You can't do it without the paradox, right? You can't do it without the paradox.
It depends on, I'm not sure whether every fractions kind of thing.
No, yeah.
You can definitely split, but I'm lazy to think about whether you can do all the fractions with it.
Okay.
That's the, you can do half and whatever with also, without this one. Yeah, you can think about whether you can, how to do a half without parallel axiom. I think that you should have in 7th grade, which you are in a regular school. How to do a half, okay? Without parallel axiom, the only rule and compass. Okay, continuity. So the first one is saying, if you have A and B, and that defines your line, and you have some segment or its length, okay, then the existent number, integer, such that A, and you go in direction of your line BC, but with the length CD, so I just write it this way, surpasses B. Meaning B is then in between A plus n times this, okay? A, B, and we have a little bit CD, which is not 0. Then after n pieces of CD, we can surpass B. Okay, B is then in between A and that endpoint C. Yeah, that's one. And the last one is that it's too hot in here, right? Just saying. All right, do you have enough air to breathe? 太热了，关一下。Okay, maybe I'm doing now. Okay, if you know, basically it says the completion of the rationals should be the real line. Okay, that's all. Meaning you have a line, and I have all the fractions, 1, 1/3, 2/3, and all the fractions on there, then all the in-between numbers are there as well. Okay. The claim is, or the theorem is, with all the axioms we had, my plane is now isomorphic to R2, to the plane with the real lines, you know. Okay? The question is how to do it, how to prove it. Let me. Tired? 累了是吧？
But now you can just create rational numbers.
No, now with the extension of the line is the line itself means. 现在想证明的是我们这个 plane， OK， 我们的这个二维的那个是 R2， 就是说 we need coordinates, right? We want to say, okay, every point here in my plane, you can identify with some x1, x2, two numbers.
And the set that x1 and x2 is isomorphic.
Yes.
To
Yeah, R2.
So we can choose, like,
So what's the first thing you need to choose?
we need to choose a point that is 0, 0.
Yes, first choose a point that is 0.
Maybe we can just make it A.
Yes. Let's write it this way. Okay. What is the second step?
choose two different lines that only
Yes.
And the angle is no.
Choose two lines.
Choose one line and.
Mm-hmm. A line. Throw 0, 0. Okay. We can choose 2 as well. Do you need any conditions on the lines intersecting at 0, 0? Can't you choose 2? What do you have? So, what's your conclusion? We can go with both and try how far we can get.
Then you should prove that all of the elements in the plane can be written as the linear combination of maybe there was L1 and L2.
Yes, but how? But how? Well, I can give you 5 minutes. You can think about it, and then we can maybe come to a conclusion on how to do it. You can discuss with your neighbors if you like.
But how about I think R3 also pull up all those.
Well, you would need R3 axioms. You would need to add something to it, right? We don't have R3 yet.
And this is 1, this is 1.
Yes.
然后因为类似两个不共性的向量，我们表示平面上所有向量。
可是 Well, you need to prove that, or maybe.
But the teacher, I think R3 also holds the axiom also holds for R3.
Well, yes, but we do. Well,
But
we
R3 is not as
但是我们可以定义一这个东西啊，我们定义了一这个东西不就好办了？然后我们又有分式。
we have what is missing for R3? We don't have. We don't have a unique parallel line. Yeah. It's unique.
Oh yes.
Point. 一点的意思，我真的不想写那么多。Okay.
You know that this is line, for example. Then you can within this. How can you prove, for example, pi is in this one? You can only prove that rational numbers are there.
Extension of a line is a line itself means that when you have.
So what does the definition of extension?
Yes, exactly. Just that when you have a sequence, that the limit will be in that. Okay.
I got it.
Yeah.
For example, the closure. Of
Yes. Is L exactly.
这不算必定吗？老师？不算必定吗？不是，这就是从拓扑的语言来讲，它的闭包的看上去，就是它是个定词。
Okay.
那就可以。
Okay, that's all right.
That's all right.
Yeah.
Okay.
反正是这个的话，就是选一个点，然后做圆点，然后选两条线，它穿过这个圆。
对。So， 这是你的圆点，然后你有两条线， 然后他们在讨论是这个两条线儿需要正角还是不正角 ？Well, I don't care. Yeah. Now you have two lines, right? But there are also all the other points. Oh, shit. Sorry. Okay, what to do with this point? Yeah? Hmm. 我们想要的是这个，是两个数值 ，yeah, x1 x2， 什么2.0？
哦，就是通过这个点这两条平行线，然后找它的交不就行？然后那不就
？Yeah. So 这个点是什么呢？
这个点的话，这个点的交点就是它的横坐标。
对 ，OK. So this is x1, x2. So this one is x1, x2. Right? OK. 现在每个点儿都有一个 coordinate. OK. What to show next? So, yes. So we have now for every point, we have that A is equal to x1, x2, and xi is in R. We have coordinates through this construction here. What do we need to show next? Wait. Right?
I think the main step is 3. First one, to prove that all the line is just isomorphism to R in it. And first you can construct first you can construct the Z and to reveal Q and reveal R.
Yes.
And the second step is that, for example, for given a line L, you consider all of the lines that is parallel to L and L itself, and it's that easy to prove that all of those ones are just the isomorphism to each other. For example, you consider an L and maybe L prime is a line that's parallel to L. Then you choose 2, 1, A and B. And just suppose L1 is another line that intersects in A.
Yes.
Then there is and only one by the axis only one parallel to L prime and pass through another point.
Yes.
So that all the set of all the lines parallel to some given given line is all isomorphic.
Yeah.
So that because of all the parallels is only given, then you can just choose, and in those in these one you can just choose one point and consider the line from that point one of the point in the line and another point, and by using that axiom you know that all of these are given by the point in these one line. And notice that line is just intersect the other line at only one point.
Yes.
And hence all of the plane is R2.
Basically, yes. Okay. And then you have to check that under this map, all your axioms are not changed, but some of these things you still need to check, right? All congruent segments are still congruent. And the same for the angles. Okay? Under this map. Okay. That's perfect. Questions? No? You have questions? Good. So let me ask you something. Now you have these axioms. Theoretically, you can do all geometry. What kind of questions would you ask? What questions?
I think the most hard step is to show that all of the set of all the parallel lines for a given line is isomorphic to R2.
Independent of this one. You know, you have now, everything is isomorphic to R2. It's unique. We are happy. It's only one plane. Okay? And now you are asked to do geometry with these things. You have your tools. What can you play? What kind of theorems you can check, or what do you think is true? What else can you do? We have that worked so hard on the axioms. Why do you need axioms? Why are we doing geometry? So what kind of questions do we want to know?
There's so much different axioms for R, and just like you can just construct R from this the natural number n.
Yeah, sure.
And also you can just choose some axioms algebraically, and also this is also a definition to R.
Yes.
And I think all of these they are all isomorphic to R, but each every axioms, for example, these are geometry axioms.
Yes. So what kind of geometry do you want to do? I'm asking about geometry. Yeah. What kind of geometry do you want to do? What theorems hold in geometry? What theorems do you know? Name some theorems. Or, well, easy ones. You can take anything. I mean, we don't want to learn definitions and then do nothing with the definitions, right? We want to have a little bit of fun with it, at least. So what do you think holds? And then next time we might do more fancier definitions or theorems with these axioms. But easy ones. What are the easy ones?
This time because you prove this prove that it is isomorphic to R2. Then many of those questions that been asked below, and that can be asked.
What? Example.
Just like and this way I think complement become a really fun, because R2 that's the mapping or a metric in it, and I think maybe we can use define congruent. How much?
Well, we can do that later. But what do you want to do with the axioms? Right? You know. Yeah, for example.
Oh yes.
That's too. I know that you know this, but before you start defining a metric, you need something like that. Without that, you don't have a metric.
But you can give a metrics just like maybe not
Pythagoras? You don't know Pythagoras? Well, but the English. Draw me the picture.
Okay.
Pythagoras is a name. Oh, you know Pythagoras theorem? You know the person?叫啥？ Pythagoras, yes, exactly. Yes, okay.
And the area of the square in this map is equals.
It's the same. That's proof the axiom looks the same. Yes, you can do it that way.
Yeah, okay, yeah.
Well, I mean, assuming you know how to do orthogonal lines, right? Okay.
Just define the area of.
Yeah, show me. Maybe you need to explain a word for the others what you have drawn, but yeah, I can talk. I'll talk about it later. I think that's the same proof.一样的。Yes, it's the same proof, but you didn't explain what you have done. Yeah, perfect. Yes. Show me later when he's done. Perfect. Okay. It is. It's the same proof, right? So this is your triangle, and you do. I just try to explain. Extend it to a square because, well, you have to show that the sum of the angles in a triangle is pi, right? So that's why this is a square in the middle, and then you compute the area of the triangles, which are the same here. Okay, you have already.
No, but can you compute the area with the axioms?
You can define. You must define the area, right?
No, but that's what I think there is a proof that doesn't use this, just with the axioms.
Well, you have to write something about. Well, if you define the idea of an area to be like that, you can do that.
Find the right angle.
Yeah, you need to do. Yeah.
That's right. You should define the triangles 2 over AB if they're parallel.
Yeah, you have to define what what is that? I mean, for that you also would need the length, right?
这块面积就等于这块面积，然后所以说这块面积它等于这块面积，然后乘以这块面积等于这块面积，然后就这种。
Oh yeah, I know this one. Yes, as well. Yeah.
Yeah, that's the one I was talking about.
Yes, but still you need the idea of what an area is.
Yeah, of course. Yeah.
But you can do this one once you have a right angle. First of all, how to construct the right angle with a compass and the ruler only. That would be one question. Do you know? That also is a regular curriculum in the 7th grade. That I know. At least in Germany it is. But okay. So do you know how to only with a compass and a ruler Okay, do a right angle. Yep. You should try. You just take out the thing and try how to do a right angle. 就是90度，怎么做90度？只用个尺子和一个圆规。
就是有一条线，然后随便。
对。
好像是在那个过直线外一点，还是过直线内一点？好像这个点在直线外面，还是在直线上？
不，你就是有个直线，然后你想做另外一个直线，然后这个是90度。
就是随便取两个。
对 ，You know how to do it? Then show me. Bye bye.
And we find 2 points.
Yes.
It is. And we notice that this is R.
Yes.
This is A. This is B. Okay. And we have a series that R must present.
Well, you can just take any. Yes. Okay. Perfect.
And this is R.
Mm-hmm.
So we got 2 points, and we use ruler.
Yes.
And we got.
So why is it now a right angle? Why? What is the definition? What is the definition of a right angle? 90度是什么样子定义的？你就说90度，我们没有这个数字。
Like this angle is equal to this.
Exactly.
Because it is on the line.
Okay. So that would be the definition. Now, how to prove that it's right angle?
I think that's just the definition of right angle.
What is the definition? As I said,
So maybe
you have that the
teacher.
yes.
So this like this is peanut movie.
Yes.
Cut it down, and we know this is actually is all the same. So we have.
So why is this the same? You should use the so. Can I? So basically, the idea is the following: you would do this, and now the question is why is this the same? Huh?
It's perpendicular.
Perpendicular? Why is it perpendicular? That's the point. That's a question, okay? So first of all, what is the definition of perpendicular? Right? Definition of perpendicular is if I have a line, I have a 0 here, I have B, and I have minus B, right? And I have a, okay? So there may be a C on there. Then the angle defined by this one is congruent to the angle defined by this one, right? Well, with the point, it's easier to say. Right? Now, how to show that this angle is congruent to this one in this construction?
Maybe. Could you maybe use X and Y? Like X and Y.
What is X and Y again?
Like R square.
Can you say it again?
Like this one.
And the R, yes?
Yeah, and then you can like go like this. Oops. And then
So the problem is you cannot draw. You can draw it in R2, but you don't, since your identification was not with just with arbitrary lines, right? They originally in the plane, they don't need to be perpendicular. So the ones that are perpendicular in R2 is not necessarily perpendicular in your plane, right? Because this identification we did before was inconvenient. We should have done one with the perpendicular, but then it's the same. The angles are the same. That would be called conformal. But, right, so you cannot draw pictures. You never heard congruence of triangles. What do you know about that? What do you know again? It's
So is side angle side is. Is a load.
Okay, because we were running out of time a little bit. So basically, the one way to do it is to show that this triangle up there, okay, must be congruent to this one, and the left one is congruent to the right one. Why is this the case?
Three sides is the same.
Yeah, exactly. For left to right, it's because the three sides are the same. Well, that's something you have to prove, but okay. But once the three sides are the same and left and right is the same, then you can do up to the upper and lower parts as well. And then you have that angles are perpendicular in the middle. Okay, or all congruent in the middle. And you have 4 same triangles, right? Okay. So that's for this. May I ask one question, okay? So, what congruence theorems do you know for triangles? There are lots of, right? They are edge, Three sides. Let me just try to.
SAS.
Okay.
SAA.
ASA.
HL.
What is HL?
SSA 特殊情况。
Huh? What?
HL.
HL.
Right angle and a side and the hypotenuse.
Okay. Well, it's one of.
3A 级景区。
That is only for
3A。
Okay. Do we have all of this now? Yes. Okay. So which one is not true? I have 2 not true.
SAA and ASA is the same. SAA.
SAA and AA is the same.
What about HL?
What is well,
HL.
yeah, well, I care less about this because it's a very particular right angle, so you have an angle already. Yeah.
Not general.
And then, well, it's one of the others because you have the right angle there as well. So one of them actually is not even true. Which one is it not true? I mean, except for this one. Another one's not true.
AAA is for similarity.
Yes, because... But there's another one not true. There's another one not true on the blackboard.
SSA. SSA is not true. There can be 2 triangles with the same SSA.
Yeah, try. Oh, I promised. Oh, are you okay? I promised him. Sorry.没啥大事儿. Okay. It's getting late. Yeah, that's basic.
没事。等等。
Thank you. Okay, so not all these, they look all this very similar, but they are not always true. Yeah? Think about the construction. You can construct those with the compass and the ruler as well, and it's not true. You can find 2 solutions. Okay? Okay. Let me end with something fun, okay? One topology question, because we did some. Okay?
Very.
I have here a picture. I want you to do an experiment, okay? That's the last question in the class. So now, I have here a picture, okay? And I have 2 needles so that I hang that picture on the wall with 2 needles.
Okay.
You know it already. That's boring.
You need to extend it to n needles or what?
I actually just wanted 2. I thought it's funnier.
2.
Do you know the question? So you have 2 needles. You would put the thing on, and the idea is when you remove 1 needle, the picture would fall down. The question is how to do it.
老师用中文说一遍。
把这个画挂在墙上，用2个针，2个钉子，去掉一个就掉下来。
现在不是掉下来。
然后呢？
怎么做？
去掉一个，
怎么挂？
掉到地上了。
怎么挂？
然后我可以
怎么把这个？
怎么挂？
怎么挂
2个钉子，然
然后可以
后去掉一个。
翻开。
Wait a sec. You need.
Okay.
Let the others think. Give the others a chance.
垂直吗？
随便取哪一个就掉，不需要啊，你可以这样子。
那2个不就得了吗
You can do this, of course, but this doesn't work, right? And you can twist it around here as well. And then if you remove one of the needles, it should fall down.
I think I did it.
You did it also before. So, I see. Then you think about how to extend it to more and what math should be done with it. Okay? What type of mathematics?
Topology.
Not necessarily, actually. It's more like algebra, I would say. So I would say it's more like algebra, but okay, you can do topology. I hold for you.
Okay.
Hola.
No, thank you. Okay.
这是什么呀？
扫描器。
啊？
实验笔。
Oh, that's cool.
都有。
That's pretty cool.
We're not allowed.
Oh, I got it. I got it.
Can we play a game? Got it.
Mm-hmm.
Remove this. Oh, that's.
Yes.
Remove this. Fall down.
Why? How to do it using mathematical language? What kind of mathematical language would you use to describe it once you have the solution? Don't look at it. Don't look at it. Don't look at it. Just think about it. Why? What kind of mathematical language? Or first of all, how to do it? You can try it out first. I just use mine. Huh?
是要求用一根吊住还是？
一个绳子，在那挂到墙上，然后我墙上有2个钉子。
就2根能挂住，一根就会直接掉下来。
对。
哦，要求这。
You can try it out.
It's like when you can like add maybe like a term, and then you also have to minus a term. Like.
Mm-hmm.
So let me think. This is this side, then wait.
不对称的话也不行。
And then I always owe you still an answer why I did Mobius span last time.
墨笔哦，
上次做的我还没跟你们解释呢，我想做的为什么做的那个原因还没跟你们解释呢。好的 ，maybe 我下次吧，已经那么迟了。
没事，反正老师我不管就行，你没有助教，待着也是待着。这次没助教，周几。
This way, and I need to go like that side sword. This way. Wait, which one is?
So, what is the mathematical formulation of the problem and how to solve it using mathematics?
That's right. And then you can try.
Okay, let me try. No, didn't work.
Wait.
这什么用？啊？
这个和这个。
Are you done?
Yeah.
Okay.
哇塞！
Can you do it again?
OK。好奇。
Think about what mathematics model are you doing? No, this is not the correct one. There's something wrong. It's not the same as last time at least.
刚的时候你是两边都对，不是这么得对称。
我在思考。
没事。有一点点。
一眼就看出来本来是那种交叉型。
所以你们几个？
What are you doing?
他们在嚼纸浆。
这个太简单了。
Wait, I think I know. Can I use it?
少。
主要是一个上面不能圈一圈，否则它就会晕住。它就只能用那种手圈上，是不是？
是的。
Can we try again?
No, this is not, because this is.
在那会儿圈一个圈儿，它不能直接套进去，它得这样。我想一下，也不能这样。
Does this work? You want to try as well?
没有，我还在想。现在脑子有点问题。
迟了，都要睡觉的时间了。
不是，老师我一般睡觉时间都比较晚。
Okay, let me try this again.
哦，我这个是。
出什么了？
I try different.
而像那个同配单位的，这个东西都不同配单位，
是。我怎么记得第一扫一步？
No,
Wait. Okay. This looks a little bit more than should be at least. This. This one? Okay. Well, I'm not sure whether
没有，刚刚还是没有下。
还是没下吗？So how to think about it? If you want to draw pictures on the thing, how do you want to think about it? 你如果画个图的话，那在纸上画图的话，就会画成什么样？那说。
Oh, teacher, I got it.
Wait.
是一样的。
It's not long enough. Wait.
Okay, I got it. Okay, wait for.
We had one correct solution already, but now you're
无法复制。
Not like this. I have another.
Close the eyes. Show me.
Okay, yes. This.
Which finger should I pull out?
Okay, pull out this.
Yes.
Yes. Now what?
Yeah.
Okay. Let me ask. What mathematics does it model?
Oh, I know.
What?
I see.
What is it?
I think there are two really main part of it.
Yes.
Just consider a length, a half of the space, and then the point in the section in the intersection of it. And this show that first the draw circles around each one is just 0. So that it makes that
Can you draw a picture for me before you're describing all these things? I cannot.
For example, there are several points. For example, P1, P2, and Pn. And we don't say and maybe it's like this. So this. And the first one, each point pi, I can use what's that? Why no? Maybe I just use this and 2 pi, and I call this gamma. But all of it equals 0, and it the main there is that the part like this is not a load, and the part of this is a load, because this, if you put out another one, then the one will not fall down, because this one is under this one.
Yeah, but how about just drawing a closed curve?
Okay.
Because we have a picture, right? We have actually a closed curve, right?
Yes.
Now, what is the...
And there are other ones, because you cannot only let this one. And for example, this one, if you all put it underneath it, then the one will jump out. And so, but the kind of this, like this, is a load.
Yeah.
Under this one.
Yeah, well, that's too complicated.
And we shall let maybe for this side, this is a pi, and if this one, if this one is up than this, is this one, then I say the sign of it equals positive 1. If this pi, then I should say that sine of it equals -1. Okay. Then one possible construction of those kind is that by letting sine of pi equals -1 to the power of I plus something for c in z mod 2z. And
maybe you can do it? I don't. I mean, the question is, what would be that it's falling down?
and
What be
if
the?
you use that, then you can prove that it will fall down. But first,
But by removing any of those?
because if you do like this, then the total one will not fall down, but all of those ones and the part of this is 0. So that
Yeah, well, it's already 0 at the beginning, so I don't want it to fall down at the beginning, right? I want to fall it down only if only when I remove one of those.
0, but you should construct this kind of thing. It will not be 0.
Well, but it's well. Let me make a suggestion. Yeah, slightly easier suggestion, because then you can actually do something and try to solve your problem there. Okay, if you just have this, just 2 points for the beginning. Okay. Okay. You call this circle 0. A curve here 0.
Yes.
You call. You can have this direction, of course.
No, actually.
Yeah. This is 0, okay? Because if that would be out of rubber, then it would just go together. It's 0, okay?
Okay.
Okay, you can call this one A.
Okay.
You can call this one B.
Yes.
Right?
Okay.
Now, if it
Okay.
goes in other,
Inverse, B inverse.
that would be A inverse,
Oh, okay.
B inverse.
Yes.
And what happens? What is the solution? If you write it this way.
I'll try it.
Yes. Or one rather. Yeah.
I use A for this and
Yes.
A equals this and B
Oh.
equals and B equals this.
Well, you can do that.
A B.
Yes, Meg. So the solution is A, B, A inverse, B inverse. Why? Because if I delete A,
Delete. Pulling out this needle. Means
yeah, and then you have B and B inverse, which is 1. And 1 means 0, and fine. So it's easier to write it this way than to try it with the string, because it is, right? So you can do that. So what is the,
Yes, and we have proved that those are equal.
yes.
and I also figure out
How to do it for n?
the 3.
3, perfect.
Okay. Alpha for this, beta for this, gamma for this. My answer is alpha, beta, alpha inverse, gamma, alpha, beta inverse, alpha inverse, beta, gamma inverse, beta inverse. Really long.
Yeah, very long, yes.
Okay. I will check if. Okay. And beta, gamma, beta inverse, gamma inverse, beta.
Yes.
Okay. The answer is this. It is not equal to 0, but it is hanged, but deleting in A inverse or beta inverse or gamma inverse will
Give it 0.
remain
Yeah.
and Lynn Heller
Yeah.
a hand.
Okay. So what is this?
You can use group theory to
Yes.
It's group theory.
Exactly.
And for example, each of these we consider all the nodes, like this, like this.
马上再给你讲一次。
All the nodes of it with with m point and like this. Actually this is isomorphic to the free product of
Yeah. Exactly.
because these are all of this A and A inverse, and this forms the D2, and there
Yes.
are n plus.
So it's a yes.
Yes,
Exactly.
and the generator and the generator is GI, where GI is the C.
Yes. Exactly.
And the solution in these in
I
this
explain it
group,
in a sec.
it just means that, and the solution in this group means that for example for a group for G element G, we write maybe maybe G I K epsilon K and the product of it, this in this one. Then the solution means that for all I for given n number that epsilon k equals 1 and I k equals n. It's just the same with the number of epsilon k equals -1 and I k equals n. So that this is just one solution. And then there's a one-to-one map to this formal definition.
So what is this group called, though?
This group is called
Free group. 自由群.
Yes, but what is this topologically? What does it mean for the thing you draw? The free group. I mean, the free group, and what does it mean for this object? Yeah.
Is that actually a topological group?
It is a fundamental group. Yeah.
Yes.
It's called the fundamental. What is this? What?
基本群.
Yes. So the fundamental. Well, it's not quite true because we have actually R3 without two lines rather than R2 without the points. But basically, that's it. It's called fundamental group. Okay. What this measures is when you have rubber and you just throw it into the space, whether it can stay extended because you have these obstructions there, or whether it goes back to a point. And that's the idea. Okay. So for this solution, okay, what we do is we define the group being when I go this way, being A, when I go this way, being B, and the inverse being when I go the other way. Why? Because if I go this way and that way, my picture will fall down, which is 0. Okay? Yeah? But I can go this way and go that way, right? And I can go back. My picture falls down again, right?
Yeah, that's right.
Is that correct? Okay, because when I write it, this configuration is A, B, B inverse, A inverse.
Yeah.
Now, when I go this way, but then I go A back and then B back, it does not fall down. Why? Because you cannot exchange. It's not commutative. Okay? So, yeah? 因为这个顺序不能变. So this is non-zero. I'm explaining to him, not to him. I'm explaining to him, and the others, not to you necessarily. Wait a sec. Okay?
A inverse is like this.
Yes.
Yeah.
Okay?
The trivial one, because actually that's just
Okay? So this is not 0. Okay? 然后你就按照这个缠。可是如果你把这个 b 给写掉的话，那 a 和 a inverse 肯定是0了，或者就是掉下来，是不是？然后你如果把那个 a 解开的话，也是，
对，
是吧？
然后
大概你可以试一试，缠一下，缠一次，挂一次。Yeah.
I think I found the
And solution, yes. Okay. Nice.
commutator.
Yeah, a lot of those, exactly. And then it's combinatoric, so like my head spins. I don't want to know.
Learn this at our topology class.
Yeah, you will. Yeah.
Professor Lee told us about
I see. Great.
你这样没套上。
Okay, so for next time, I will go on with the triangles because there are theorems of projective geometry using triangles. Okay? And actually, there are complicated theorems, and then we will do cross ratios and so on and so forth. So we now start working with these axioms. Now you used to think as a homework, okay? 但作业啊，有什么问题可以提？ So what kind of questions can you answer with these axioms? Geometry. Yeah? Yeah? About geometry.
Yes, okay.
About geometry. Restriction.
I think there's a really fun question about this.
Okay.
And actually, there's background.
No. I don't want. No. Easier questions. We can do that later.
We know that all of these AB, E minus F plus V minus E plus F equals 2, right?
Yes.
How about these? You give a torus like this. For example, this is a torus, this is a torus. Then we know that V minus E plus F equals 0. And if we just add the torus of another torus, like this, one more. Yes, one more torus, then it becomes -2.
Yes.
We know that the total one, for example, there are n torus.
Yeah.
Then we know that is 2 minus 2n. How to prove it?
We can do that, but this is 3D. I want to just plane first. On a plane, simple. First of all, just
And actually, the n is the genus of it.
genus.
Genus, okay.
Genus.
Genus 规格
Yes,
规
cool.
格
Yeah, so to think about what kind of question you can ask on a plane, okay? And actually can get very complicated. These theorems look complicated, but they're very fun it's somehow invariant in geometry. But you have to come up with the questions first, okay? That we will do next time. And then in 2 weeks, we try to do the soap bubble thing. And till then, I need to repair this problem that these angles are not working. Okay? And then we can discuss about what it means, right? That these soap bubbles. And you can think about how they might look like and whether the solution is unique. Yeah? Meaning, when I put it in the soap, whether I know what comes out or not. Okay? Okay, thank you.